Hi, my name is Ramji, and I'm here today to talk to you about what the Costco hot dog can teach us about the immune state. One of the big problems in drug development is if you're designing a drug that targets the immune system, you might get a lot more than you bargained for. And that might seem a little bit odd because if you're designing a missile that hits a target, well, throw the missile at the target, and target goes boom. But it's not that simple in human biology. When you're designing a drug that, say, targets T cells, you might hit a different part of the immune system, like B cells, and make the B cells go boom. And that can be very good or very bad depending on the setting. And if it's very bad, it could lead to things like severe toxicity or maybe even death. So as a result, scientists have developed a technique called immune profiling to analyze exactly what part of the immune system the drug is hitting. The challenge is current immune profiling technologies are quite limited. One technique that's very popular is called flow cytometry. This only allows you to analyze a subset of the immune state, say 6 to 12 markers. And that may force you to ignore other important immune states like myeloid cells, NK cells, B cells, etc. These are very important cell types, and missing these could impair your understanding of the drug's overall function. To see why looking at a subset of data might impair your understanding of a problem, let's look at a different, completely parallel problem, measuring inflation. What if we just use one price in the economy to try to measure inflation? And imagine if we went to Costco and just looked at the hot dog and soda deal. We might conclude that there's 0% inflation in the economy because it's been $1.50 since 1985. But as you look at dozens of different prices in the economy, like milk, gas, food, et cetera, you start to see that true inflation might be a lot higher, maybe even close to 10%. So this kind of reasoning can be applied to flow cytometry, and as a result, there's a new technique called mass cytometry that's emerged to solve this problem. Rather than just look at the proverbial hot dog, i.e. the T cells, you can look at these dozens of different other immune cells in one sample, myeloid cells, dendritic cells, et cetera, and get a complete picture of what's happening in the immune system. To see this in action, let's take this one example. If you looked at a 8-marker panel, a conventional T cell panel, and use this to analyze checkpoint blockade in melanoma, you might have missed some very important cell types that predict progression-free and overall survival. Building upon this technique, my co-founder Matt Spitzer published in Cell Reports 2019 on comprehensive immune monitoring for clinical trials. Using single-cell mass cytometry, they analyzed peripheral blood, computed an individualized fingerprint of response looking at dozens of different immune cells, millions of data points. This kind of technique is called high-parameter immune analysis. And if this sounds interesting to you, contact us at takeo.bio.